So the way that this would show up on an exam is they would give you the formula. So let's say they gave you the formula in this form, where n is the number of compounding periods per year, p is the principal, and r is the interest rate. What you would then do is plug everything into the equation. So we will have a principal of 1,500. The interest rate we always change to a decimal, so decimal 0.4. Compounded quarterly is 4 times per year. We want to find time because it says when will the amount be 2,500. So the amount over here we can put in as 2,500. And this is the big idea of what this chapter is going towards, because what do we have to do? We have to solve for t. And throughout the years, you've slowly been developing algebraic skills for solving for x. Do you remember your very first ones? Here's sort of a historical thing. Ooh. That was the very first solving for x ones you guys had. Right? And you learned techniques, like you had to subtract 3 on both sides. Some of you just said, I can just see it. I know it's 2. And then as time went on, you learned new techniques. What happens if you have an x squared? Well, you have to square root both sides. What happens when you have an x squared and another x? Well, then we introduced the idea of factoring to solve. And now we've factored so we could do x cubed once. You've learned how to solve for x when it's inside sine, cosine, tan. So that was another technique that you add to your algebraic skills. Okay? But the other day, I asked you to solve for x in an exponent, and all we could do was guess and check until we got it right. And then I showed you on the calculator, oh, there's some log buttons. And yeah, we don't know how to use those yet. So that's where we're going towards in this chapter. We're enhancing our algebra skills even further to be able to solve for x in exponents. But we haven't learned that yet. So now we have to think, if I haven't learned that yet, how could I solve something like this? You could guess and check. Could simplify a few things. What could we simplify? We could simplify inside the brackets to just get 2,500 equals 1,500. This will be 1.01 to the power of 4t. And we could graph it. That right now is, with our graphing calculators, probably our best strategy. You could put this into y1. Now, if you have a calculator that the exponent goes up like that, then you can write 4x in there, just like we see it. If your calculator just does a little hat button, you have to put that 4x in brackets to make sure that it's all in the exponent. Okay, now when I hit graph, probably nothing's going to show up, so I'm going to start off with going to zoom fit, which is zoom 0. And just seeing what happens when I graph that. Wow. Wow. Did I oh, there it's going up. That's what my zoom fit ended up looking like. Yes. Did I type in something wrong? Let's see. Yes, it should be 1.01. Which will change my second insert, 1.01, and then I'm going to zoom fit it again and see what it decides to do, besides the fact that it's really slow. So there's my straight line at 2,500, and there's my exponential growth. Will they intersect? Yes. This is the fastest graphing calculator that exists. So then I can go second, calculate, where do those intersect? Number 5, enter, 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 and at 12.8. So this would indicate 12.8 years is when the amount will be at 2,500. So right now, all we can do to solve these is use our graphing calculator. Questions number 12 and 13 you can do that are like this.